All right, for this video, I'm going to do some trigonometric identity problems. No. Okay, so using the Pythagorean identity, the first thing we can do is come up with the other trig functions using, say, one of them. So, like here, I know secant is now. Your textbook is kind of mean. It wants all six: sine, cosine, tangent, and their reciprocals, secant, cosecant, and cotangent. But the packets are a little nicer. They let you forget about these. If I could take sort of a compromise, I'll use this as the clue, but then only require we find sine, cosine, and tangent. And based on that, the first one we can find is cosine. The beginning of the second syllable is the one that it's the reciprocal of, so this is the reciprocal of cosine. So that means the cosine must be 3/4. Okay, now another method, what you learned in class today was that, okay, now you plug that into cosine squared plus sine squared equals 1. I'm just going to abbreviate because it's hard to write with this thing. We could plug in 3/4 squared and get 9/16 plus sine squared equals 1, or 1 is 16/16. So when we subtract the 9/16 from both sides, we get sine squared equals 7/16. And so sine, square rooting both sides, is square root 7/4. However, I have to add in that the problem gives me a domain. The domain it gives me is 3π/2. And by the way, this is number 5 on page 852. Page 852, number 5. And now we just solved that sine would be 7π/4, but hang on, the problem states that 3π/2 is less than theta is less than 2π. That means, what quadrant are we talking about? We're talking about the fourth quadrant, where sine is negative, cosine is positive. So sine is negative root 7/4. And tangent is sine over cosine. We can just, the denominators would go away, and we'll get tangent equals negative root 7/3. So that's what we learned to do in class on Tuesday. However, what we can add to that is another method. As soon as it's not really adding much, we can say cosine is adjacent over hypotenuse. So this becomes adjacent, this becomes hypotenuse. So 3 squared plus what squared equals 4 squared. And so it's 9 plus, and it turns out it's 7, 4 squared is 16, 3 squared is 9, so s squared is 7, so root 7 is my, opposite. So I basically got, you can sort of sneak back into the old triangle language and solve these that way also, but you're using the Pythagorean identity no matter what. Okay, what I just said there probably didn't make a lot of sense. If you need me to explain it more clearly, email me and I'll make another video doing so. But if this way works for you, this way is good enough. Now, let's look at number 9, still on page 852. It says, simplify the expression secant x. Let's pause the video and all. So number 9 is like this. So what we can start doing is just looking at these things as variables themselves. They behave like variables. And that's just something that we start, we're doing with algebra, period. So secant, this is something plus 1, variable plus 1 times variable minus 1. Well, that you've never seen that before, but you have seen something like this before. And what was the answer to this? X plus 1 times x minus 1. If you said x squared minus 1, I agree with you. Therefore, this behaves the same way. It's going to be secant x squared, but using our new notation for squaring the whole secant of x, we're going to call it this. It means the same thing. Now, what were our Pythagorean identities? I don't remember what the one having to do with secant squared of x was. I just remember sine squared x plus cos squared x equals 1. But I remember that I got these other identities by just dividing by either sine or by cosine. So, and if I want secant, probably going to have to divide by cosine. 1 divided by cosine gives me secant. So I'm going to divide everything by cosine squared x here, and I'll get, dividing the whole thing by cosine squared x, dividing the whole equation, I'll get sine squared x over cos squared x, that's tan squared x. This is an identity. This is separate from this equation we're solving over here, or this expression we're simplifying over here. I'm going to use this identity. But what is this identity? It says tan squared x plus 1 equals 1 over, oh, cool, 1 over, it's not that cool, Mr. Dimmer, I know, 1 over cosine squared x, which is secant squared x. Well, now, if I subtract 1 from both sides, I know that secant squared x minus 1 is tan squared x. So what this problem really is tan squared x over tan x. And just like x, you've never seen that before, but you have seen this before. Ooh, is that blue and dark blue? Looks kind of nice. X squared over x equals x, right? Tan squared x over tan x equals tan x. And that's going to be the final simplified expression. That's as simple as we can get it. All right. I may have one time for one more. We'll do number 10. We'll do number 13. Cotan x times tan negative x equals negative 1. All right, what do we see right off the bat? A tan negative x. So this is a theorem. It's on page 848, where all your theorems are, but it has to do with tan being an odd function. So tan of a negative something is negative tan something. So this is cotangent x times negative tan x. So we can get that negative x out of there and just make that negative. And then that just, a positive times a negative makes this whole side negative. So basically I'm going to change this to negative cotan x tan x. We can't always do that. It's not straight multiplication. We can do it with tangent. Tan negative x equals negative tan x. And then that negative I move to the front. Clear? Not really? Well, too bad. I'm sorry, I shouldn't say stuff like that. But, and what we're doing, we're verifying the identity. So actually, we're going to prove, it says we're verifying the identity, so we just want to prove that this left side is going to equal negative 1. So first we do negative cotangent x times tan x, cotangent x times tan negative x. I'm going to have to trash this one. Or, you know what? I like the first example I showed. I'm not going to finish the second example. I'm running out of time. So stay tuned for part 2. Or maybe I'll pause it and be able to finish it later. Okay, let's just try it right now. The key thing, though, that I basically wanted to make sure that was different about number 13 and number 9 is number 9 was simplify. Remember, way back over here, when we simplified this and got this. But number 13 gave us an equation, but it says verify the identity. So it says verify the identity, and what that means is prove that this is true all the time, or simplify the left side so that it equals the right side. So simplify the left side so that it equals the right side. So I just should ignore the right side and just start simplifying the left side just like I was simplifying the other one before. So my first step, I didn't use the right side at all, got like this. Cotangent x times tangent x. Well, what is cotangent? It's 1 over tangent x, right? And you guys can see that we're almost there to actually getting this done. Because tan x over itself is going to equal 1. That's supposed to be a t, but this is negative, and so something reciprocal times its reciprocal equals 1, so the whole thing simplifies to -1. I just verified this identity here. It equals -1.